All right, on this, we're just going to go through the transformation notation just a little bit more, talk about it a little bit more depth. This equation here, the 2 times x minus 3, quantity squared plus 4. What they're doing here is they're transforming this into standard form, which is right here that we talked about. So to do that, instead of what they did was they expanded the x minus 3, quantity squared, and made it x minus 3 times x minus 3. Foiled this, of course that's F-O-I-L, okay? Combine the like terms, and then distribute it in the 2 once they combined. At that point then, these two were like terms, so this 4 at the very end gets added in with the 18. And so this and this are actually the same parabola, the same equation, just the 2 different forms. Vertex form, standard form. All right, but of course they're both quadratics. All right, there's our 2 forms again. Make sure you know those. All right, here it's talking about the different values, A, H, and K inside the vertex form, which is this right here. Excuse me. Now, when you determine what A is going to do, you only look at the number A itself. You don't concern yourself with the sign, because remember we said the sign just determines whether it opens up or down. So, if A is greater than 1, we talked about that that's going to stretch it. So, well, let me go back, sorry. It's going to stretch it vertically. So it's going to look like this, real skinny. The bigger A gets, other than the negative, not keep the negative in mind, it's going to get real skinny. The smaller A gets, if you have a fraction, it's going to get fatter and fatter and fatter because it's being compressed, okay? So this is a vertical stretch when A gets bigger than 1. It's a vertical compression as A gets smaller, closer to 0, when it's less than 1, okay? Of course, K is the Y part of the vertex, and that's what shifts the graph up and down. H is the X part of the vertex, and that's what shifts it left and right. And remembering that it does the opposite of what you think it should. Okay? Okay. What we're going to do is look at a couple examples here. Just go through the different questions you should ask yourself when you start to graph a quadratic that's written in vertex form. Okay? So everything we're doing right here is going to be, oh man. All right, let's try this again. Everything we're going to do here is going to be in this form. Not sure why it's acting crazy again. That's okay. All right. So in this first question, we're going to answer each one of these questions. The first question is, state if there is a reflection over the x-axis. Well, what do we look for? We look for to see if there's a sign, a negative, right here in front of these parentheses. There's not. So we're going to say that there is no reflection. Identify any, meaning that if it's upside down. So this thing's going to open up for sure. Okay? Identify any vertical shift. Okay, vertical shift is always the last number, and it does exactly what it's supposed to. So that number, so that means it's going to shift vertically up 4 units because it's positive 4. The next question says, identify any horizontal shift. A horizontal shift, you're going to look to the parentheses. Remember, it's the opposite of what it should be. So since this is minus 2, it's going to be actually shifting to the right 2 units horizontally. Identify any vertical stretch or compression by what factor? You're going to look for A. Well, A is just plain old 1 here. So there is no stretch or compression. It's just a normal, looks like y equals x squared. Okay? Except that the vertex is shifted around a little bit. So you're going to say no vertical compression or stretch. The next one, it says identify or determine the standard form of the quadratic equation. This is what you should come up with, because we practiced this yesterday in the warm-up, or this morning actually in the warm-up. Remember the shortcut to do that? Excuse me. A plus b squared equals a squared plus 2ab plus b squared. Because you're going to have to do that a lot on these. That's another reason why we need to know that shortcut. So if I do the shortcut here, make my pen a little bit bigger. If I square x minus 2 squared, that's going to be x squared. The middle term is 2ab, so x times negative 2 is negative 2x times 2 again is negative 4x. And then square the last term for b squared would be plus 4. Okay? And then, of course, we have the plus 4 on the very end. Don't forget him. You've got to add him in also. So when we look at that, we have x squared minus 4x, but then this makes 8. So that's where they get that 8 from. All right? Okay, the next one says sketch the graph of the quadratic parent and the given function. So if we sketch the quadratic, uh-oh. Go back. All right. The parent is in blue here, and the new graph is in red. So we don't have reflection, so it still opens up. It's shifted up 4 units, 2, 3, 4, and right 2, so its new vertex is right here. And then it has no vertical compression, so it's going to look just like the original, same size and everything. And one thing I want to point out here that's important that you understand, if you go out 1 unit to the right or to the left, you should only be 1 unit up, because this kind of goes back to our little table. If we're doing y equals x squared, and this is x and this is y, if I only go 1 unit, then 1 squared, okay, equals 1. If I only go 1 unit to the left, then negative 1 squared also equals 1. So that means you should only go up, you should only go right 1 and up 1 to get to the next point. If it's farther up, like if it's at 1, 2, or if it's at 1, 3, then that means there's some kind of stretch there. If it's half that, or looks like it's a third that, then that means it's some sort of compression, okay? So just watch for that in the future. All right, so we're going to try to answer these same questions for this next equation. So real quick, we're going to decide if it reflects or not. Again, there's not a negative out in front, so there's no reflection, okay? Okay, so this thing's going to open up for sure because it's positive out in front. The next thing is, does it have vertical shift? Again, you're going to look at the number at the end for that. That's k. So this is going to shift vertically up, not up, down 4 units. Vertical down 4 units. Okay? All right, then we're going to decide it as horizontal shift. Horizontal shift, we look here, it's the opposite of what it should be, so that's plus 3. So this is going to shift horizontally left 3 units. Next one is vertical stretch. All right, now we do have an issue here. We have a 2. So what that means is that it is going to stretch it, not compress it. So this is going to be a vertical stretch by a factor of 2. So we'll say times 2. Okay? So what that means is instead of that going right 1 and up 1, when it goes right 1, it's actually going to go up 2. Okay? So we think about it this way. Now we're kind of doing y equals 2x squared. Not, if we just zero in on the compression. So if I plug in 1, if I do 2 times 1 squared, well, I'll do 1 times 1 squared is 1 times 2, it gives me 2. So that point up here that was 1, 1 now becomes 1, 2. Same thing for negative 1. oh, excuse me, pull that back over. Same thing for negative 1. When I plug in negative 1, when I square negative 1, I get 1 times 2 is 2. If I do that for, let's say, a bigger number, maybe I do 3. If I do 3 squared, normally I should have a point at 3, 9. But instead, I get the 3 squared is 9. I have to go back and multiply it by 2. So when I go 3 units over, instead of going up 9, I actually go up 18 because I'm going twice as high. Okay? All right. So vertical stretch times 2. And then on E, it says find the equation. So we're going to take this equation, and we are going to, I'm going to do the work up here a little bit where I got a little room. We're going to do the shortcut real quick to do x plus 3 squared. So we did that in class. That would be x squared plus 6x plus 9. You can see where that shortcut will save you some time. Minus 4. All right. I got to distribute the 2 to get rid of the parentheses. So that's going to be 2x squared. Y'all please do this neater than I'm doing it. I just don't have room below. 2x squared plus 12x plus 9. And then, of course, we got the minus 4 on the end. So now I can combine those two. So my actual equation is 2x squared plus 12x plus 9 minus 4 would be 5. And that would be my equation. So, hang on. If I show all these rules of my graph, this is what my new graph would look like. Again, here's y equals x squared. It's shifted down 4, left 3. So our vertex moved down 4, left 3. And then our vertical stretch, notice where I was talking about that this thing should go through, if I go 1 unit over, it should go through 1. It actually goes higher. It actually meets here. So let's show that. So instead of being up right 1, up 1, it actually goes right 1, up 2 when it hits the full unit again. Okay? And same thing over here. Instead of when I go, if I square 2, this should go right 2 units, up 4. But this thing actually goes right 2 up units. 4 times 2 is 8. So it actually doesn't even hit till way up here. Okay? Where I go 4 units up. All right. Go ahead and finish number 2 and 4, and we'll work on the rest in class.